Well, good morning, everybody. I thank you so much for being here. And I will try to explain, after talking about culture of doors, talking about development, historical development of doors, and after talking about the economics of some European regions, I will try to talk about the performances of door. In fact, wooden doors can also be used not only for interiors, but also for fire resistance and also for soundproofing reduction. Well, there is a long tradition in Italy in door construction. Professor Frattari has made a very good relation. But only in the late 80s, someone started studying the possibility to make fire-rated wooden doors. In Trento, there is an institute that is called now CNR Ivalsa. And in the late 80s, they've started testing fire-rated wooden doors. Well, this is the first certificate, the first test report we had in 1987 at the Ivalsa Institute. According to the current standard, that was an Italian-only standard written in 1961. In 2005, we had the first test report according to the European standard, published in the year 2000, and let's say fruit of the long studies coming from European technicians all around Europe. This first test, just to clarify what is changed between one standard and the other, what has changed by the technical point of view indoors. In the Italian standard Circolare 91 of 1961 to the European standard EN 1634 Part 1, there was an Italian standard that was the UNI 9723, written in 1990. Well, what has changed? In the 1961 standard, the time temperature curve was described, while in the European standard, it's referred to an ISO standard. The number of thermocouples, it means to verify what Mr. Nonaka said. The temperature on the not exposed face of a door, of a wooden door, must be verified during the test. We have a 1000 degrees temperature inside the furnace, and we evaluate the temperature on the unexposed face. In the old standard, 5 thermocouples were enough. On the same door, single leaf, now 22 thermocouples are needed. The furnace pressure control, it's completely different. There was an Italian standard, now it's a European standard, and it's quite different how the pressure control is performed. And last, the test sample for each ITT, initial type testing we do, changed from one sample, one side, let's say hinges inside the furnace, to 4 samples. 2 samples must be tested inside, opening inwards and outwards. 1 sample must be cutted by the laboratory to verify if all the description we have in our test report correspond to the sample, and the 4th sample is, let's say, an evidence for further test. This is the only temperature graph we have in the 1987 test report. You can see there is a little difference between the new test and the old test. There is a lot of new data. There is a lot of new things that are verified during the test to let the experts analyze what the door is doing and to give some more information about the door. By the technical point of view, just to clarify, I refer to 2005 because it's the first test we've performed according to the European standard, but actually our company has more than 10 tests made according to the European standard, and there is a testing program for 2012 and 2013 of 8 new tests. Well, this is the only drawing we have in the old system, in the old certificate. In the new certificates, we have many more drawings. These are only 2 of them, defining and clarifying all the materials inside, all the characteristics of each material, and all the performance of each material. Well, green building is for sure one of the new goals that a company must have. So it's not only depending on the, let's say, it's fashion now to say green building, but it's really important also by the industrial point of view, because the core materials changed completely, the weight reduced, and also the cost have reduced a lot. There is a lot of new finish possible, and the biggest part of these finishes can be considered as green materials. And it's not only finishes, it's also an architectural point of view. We said before, during some historical periods, the doors were hidden, let's say, in the wall. Now we have developed new doors, fire-rated doors and sound reduction doors that are completely hidden in the walls, for example, but not only. So, as Professor Frattari said before, the new goals are the improvement of the quality and enlargement of the product range. We need to make easier customization based on industrial products. We use new materials for finishings like the TSS, thermostructural surface, and the stone veneers, for example, that is a new frontier for doors, I think. We will invest, and we are still investing in green products. There are lots of different possible solutions by the architectural point of view, like these 3 you can see, but this is just to clarify that it's possible to do luxury doors or historical doors, and also design doors, much more modern doors, let's say, with different finishings and a lot of possibilities for the architect. We have here some examples of doors installed in hotels in Italy and abroad. For example, this is a TSS material, so this is not typically wood. This is a wooden door, but it's finished with this new material that is called TSS, that is a paper-based finish. This is an historical door in Venice. We were talking of the typical finishings of the south of China with the black and the gold finishings. Typically, Venice is very often, you can very often find these kind of finishes in the historical Venice buildings. Well, this is an example of a door that is inside the wall. This is a door, an hotel door, by the pushing side, and it's completely flush with the boiserie, so with the covering of the wall by the pushing side. And we can do it exactly in the same material. It is also possible to work on colors, like, for example, this is an HPL finishing that is needed for a school in this situation. This is an hotel where we've been working on wood veneers, high quality wood veneers in this case. We were talking about the multipurpose doors. For example, these are 2 fire-rated doors where the acoustic performance required is 41 dB, where the escape route function is required, and where also the access control is required. By the other side, you can enter only if you have a card, let's say, that allows you to enter. And it's with the same finishing of the wall cladding made by others. This is an example of a conference room in Rimini. This is a very big project finished last year. The finishing is only, all the doors are veneered with beech. All the doors are 2 hours fire rated with 41 dB of sound reduction, and also these doors have both the escape route function and the access control function. Just for an example, the architect here was the German study GMP. For example, they have made the train station in Berlin for the Olympics. And they have asked for the doors to be completely flush both sides. So the pushing side and the pulling side that you see here are completely flush with the wall. And once again, the door is part of the wall. This is another pair of doors where you see also the closing system, the closing device. On top of the left door, you can see an exterior closing device that also has the function to coordinate the closing sequence. I mean, firstly, you must close the secondary leaf and then the primary leaf. It's also possible, and we have tested doors with concealed door closers and with concealed hinges, just to go to the requirements of the architects today. Once again, doors in Venice. This is another example of door disappearing in the wall. This is a 30 and 60-minute door tested according to the European standard. This is a photo by the pushing side, and it's not a door flush with the boiserie or with the cladding, let's say. It's a door flush directly with the wall, with an aluminum frame, concealed hinges, concealed door closers, and in this case, a wall finishing also on the leaf. Well, this is an interior doors, and this is my company. I thank you for your attention.